Hello, hello. Okay, okay. Yeah. Okay. Anything you want to do? You want to do the theory paper, or you want to do multiple choice, or you want to like discuss any points?
I think we can go through the theory paper.
Okay. Yeah, we'll start from the end, yeah? We'll start from the end. Okay. Okay. Yeah, so 2023. Okay. Yeah. So if you take a look at the question, you find that they are quite easy, and then they repeat after some time. Yeah. So there are many questions that come up time after time. Okay. Yeah. So like this one, identify lattice structure of copper. Okay. Easy. Okay. Metallic. Okay. So it's metallic bonding, but if you look at the marking scheme, they put the term giant metallic. Okay. So you need to give like both words to get the full marks. Okay. For A levels, it's more specific. Giant metallic. Draw a label diagram to show the bonding present in copper. So this is just the metallic bonding structure. Yeah. Okay. So straightforward. Yeah. Okay. So essentially, we just need to draw something like this. Okay. So positive, okay, cations in a sea of the localized electrons. Okay. So we just need to show this. Okay. This gets asked quite often. Okay. Yeah. Okay. So we just need to show this. Okay. Yeah. Okay. So some details. So we need to show the circles containing just a plus do not have to be labeled. And then yeah. Okay. And then circle surrounded by electrons shown as E negative or negative. Okay, so these are some of the details. Okay, and then this one, describe covalent bonds present between carbon atoms in an ethene molecule by completing table 4.2. Okay, yeah, so it's kind of like this. Okay, so this ethene, two carbon, okay, two carbon alkene. Yeah, okay, two carbon alkene, sigma bond. Okay, so sigma bond will be, okay, this one, two, three, four, and then one of the double bonds. Okay, sigma bond. Okay, type of orbitals involved in the bond. Okay, type of orbitals involved in the bond. So okay, so they are asking about whether is so for this one, okay, for carbon, carbon has 6 electrons. Okay, so 1s2, 2s2, 2p2. Okay, so basically it's like this. Okay, okay, so this orbitals of carbon. Okay, but to form this carbon ethene, you cannot simply take this uh S and P orbital to react. Okay, we cannot simply do that. We need to hybridize first. Okay, so in this case, what kind of hybridization? SP, SP2, SP3. Okay, which one? So this one, we can see the bond angle is 120. Okay, so when we have 120, it's going to be SP2. Okay, SP2. So the first step is we will, before we hybridize, we need to just put one electron in each, okay, orbital. So we need to separate the electrons because each of them will form one bond. Okay, so we will put them in separate orbitals first, and then we are doing sp2, so we will take one s orbital and two p orbitals. Okay, and then we will hybridize, okay, to form 3 identical, okay, sp2 hybrids. Okay, so we take this one and then this one, we hybridize to form this. Okay. Okay, so we take the 2s, 2p, 2p, it turns to sp2, sp2, sp2. Okay, so we take these three orbitals, we hybridize into three identical orbitals. These three identical orbitals, they will be arranged, okay, as far away from each other as possible. So that's why we have this 100-degree bond angle. Yeah, okay. So how the orbitals overlap, because they are sigma bond, so there will be um direct overlap. Yeah, so there will be direct overlap like this. Okay. So first carbon and then second carbon. Okay, direct overlap. Okay. So our answer like this, okay? sp2 react with sp2 and it's a direct overlap, okay? So just now we take one S and 2p we hybridize and then we still remain one that is unhybridized, okay? Unhybridized orbital, okay? So these unhybridized orbitals, they will be kind of okay, let me show the picture. It's easier. Okay, so the unhybridized orbital, and on. Okay, yes. Okay. So the unhybridized orbital, they will overlap sideways to form the pi bonds. Okay. Yes. Okay. So we also have the pi bond. Okay. Sideways overlap to form the pi bonds. Okay. Yeah. So we end up with this. Okay. Okay. So this one, 2p, is this 2p here. Okay. That is unhybridized. Okay. So we'll take them to do the sideway overlap. Okay. Between the two carbon. Okay. Between the two carbon. Okay. So we take the unhybridized p orbital and then they are in the suitable position to overlap sideways. Okay. Yeah. So we get the pi bond there. Okay. So that's the idea for this question. Okay. So 2023. Okay. 2023 question. Okay. Okay. Draw a diagram to show the formation of the strongest intermolecular force between two molecules of the ammonia. Okay. So ammonia is like this. Okay. Okay. So we have polar bonds and then we have a lone pair. So the direction, okay, of the electron, okay, will be towards the lone pair. Okay. So this is a polar molecule. So it will have ID. Okay. ID is present for all molecules. And then it will have a permanent dipole also. And then it will also have hydrogen bonding. Okay. So it has all three. Okay. But they are asking the strongest intermolecular force. So it's going to be the hydrogen bonding. So we will focus on how to show, okay? How to show the hydrogen bonding, okay? So how to show the hydrogen bonding? So it's like this, okay? So we have the nitrogen, okay, which is bonded to the hydrogen, okay? So nitrogen bonded to the hydrogen, okay? And then because it has a permanent dipole, so we have delta positive and delta negative. Okay, so like this. Okay, nitrogen bonded to 3 hydrogen. Okay, now this nitrogen, it will form a hydrogen bonding with another hydrogen that is at another ammonia molecule. Yeah, okay, like this. Okay, yeah. Okay, so this is the hydrogen bonding. Okay, okay, yeah, okay, okay, yeah. So it's something like this. Okay, so if we look at the marking scheme, what's the requirement? Okay, the link shown as a dashed line between the lone pair of electrons on the nitrogen on one ammonia to the other ammonia. Okay, minimum 3 correct partial charges. We need to show the partial charges. Okay, and then we need to show, okay, the hydrogen bonding as dashed line. Okay, so that's the idea. Okay, name the strongest intermolecular forces between the ammonia molecules. Yeah, we just did that. Okay, hydrogen bond. Okay. Okay, define electronegativity. So you may find later this question gets asked a lot. Okay, so we already discussed that. Power or ability of an atom to attract electrons to itself. Okay, the more electronegative it is, the more it will attract electrons to itself. Okay, explain the difference in the melting points of magnesium and sodium chloride. Okay, so we can see here magnesium, okay, and sodium chloride. Okay, so what is the bonding in magnesium? What is the bonding in sodium chloride? So we know that, okay, metallic and ionic. Okay, metallic and ionic. So we can see that magnesium is having lower melting point than sodium chloride. Okay, so which is telling us that the ionic bond in the sodium chloride is stronger than the metallic bond in magnesium. Okay. Yeah. Okay. The bonds in sodium chloride are stronger than the bonds in magnesium. Okay. Okay. Name the type of reaction that occurs. Okay. So we better start here. Okay. Yeah. Okay. Okay. Te reacts with F2 to form TeFX. Okay, molecules of TeFX are octahedral with bond angles of 90. Explain why TeFX is octahedral with bond angles of 90. Okay, so whenever we see octahedral bond angles of 90, which means we have six, okay, six bonds formed around Te. Okay, so if we look at the periodic table, Te is in period 5. Okay, Te is in period 5. Okay, let me show quickly. Okay, where is Te? Okay. Yeah. Okay. So Te is here. Okay, period 1, 2, 3, 4, 5. Okay. So period 5, which means it has um additional empty orbitals. Okay, so it's got extra like d orbitals, f orbitals to expand the octet. Okay, so it's possible to have more than 8 electrons around the Te. Okay, so yeah, so in this case, if we are given that it forms octahedral, so means it's like this. Okay, so we expect the structure to be like this. Okay, YTF is octahedral with bond angles of 90. Okay, so because it has a 6 bonding pairs of electrons, okay, or coordination number of 6, okay. And then the bonding pairs, they will repel each other. Okay, they want to stay as far each other as possible, so they will form the octahedral shape. Okay, so now we already know that it is TeF6. Okay, construct an equation for the reaction of TeF with water. So this is a later topic, so we don't need to know at this moment. So we just quickly go through. Okay, yep. Okay, so this is called hydrolysis. Okay, so this later topic. Okay, yeah. Okay, this is also 2023. Reaction mixture is cool to collect this, this molecule here. Identify the type of van der Waals forces that are present. Okay, yep. So if we sketch it, it will be clearer. Okay, CH3, okay, CH2, okay, CHO, okay, okay, CHO. Okay, yep. So if we see CHO, it is actually what we call that aldehyde. Okay, it's aldehyde. It's not alcohol because if we put as alcohol like COH, so now the C is not forming four bonds. Okay, so it's incorrect. We want it to be forming four bonds, so it must be aldehyde. Okay, because it's not alcohol, it does not have hydrogen bonding, so it is only should be just the ID and PD. Okay, so it's got the instantaneous dipole induced dipole, which is present in all molecules, and it's got the permanent dipole because of this polar bond here. Okay, yep, no hydrogen bonding. Okay, okay, so we are given. Complete the table by placing a tick to show which of the compounds have molecules with overall dipole moment. Okay, overall dipole moment. So first, we want to see whether polar bonds are present. Okay, whether polar bonds are present. Okay, all of them have polar bonds. Okay, so all of them have polar bonds. Okay, so this is step one. Okay. Okay, so all of them have polar bonds. Okay, now we want to look at the symmetry. Okay, symmetry, whether they cancel out or not. Okay, so for CO, okay, the oxygen is more electronegative. Okay, so it goes like this, but because of the symmetry, it cancels out. Okay, so it cancels out. So the CO2 has no overall moment. Okay, SO2, so yesterday we already discussed the structure. So the sulfur, after bonding with two oxygen, it still has one lone pair. Okay, so it still has one lone pair. So it's not symmetrical. So it will have a dipole moment. Okay, so CSS. Okay, so this one CSS. So again, it has a okay, polar bond, two polar bonds, okay, but they do cancel out each other. Okay, so this one has no um overall dipole moment. And then we have the SCO, okay, SCO. Okay, let's see. Yeah. Oh, yeah. Okay, SCO. So we can see they have, okay, different electronegativity value. Okay, C and S is almost similar. So oxygen is having the is most electronegative. Okay, most electronegative. So it will be the direction is towards oxygen. Okay, so it's going to have a dipole moment. Okay, these two. Okay, suggest the shape of the molecule of the H2S. Okay, So H2S, okay, I will give the structure straight away. Unless you are not sure, we can go through like how to do it. Okay. If not, to save time, I just give it straight away. Okay. Yeah, it's like water. So it's like this. Okay. So this one, because we have the two lone pairs there, is going to have a non-linear shape. Okay. Or bend shape. Okay. Okay, next, draw a dot and cross diagram of lithium hydride. Okay, lithium hydride. So to draw this dot and cross diagram, we need to know at first, okay, how many proton, how many electrons. Okay, hydrogen, how many proton, how many electron. Okay, so if we look at the periodic table, lithium is 3. Okay, hydrogen is 1. Okay, okay, lithium is 3. Okay, hydrogen is 1. Okay, so lithium, okay, you see, include all electrons. So not just the valence shell, so it's including outer shell as well. Okay, so lithium, okay, example. Okay, so 3 electrons. Okay, hydrogen is just 1 electron. Okay, so now lithium, to make a full shell, okay, it will lose 1 electron to the hydrogen. Okay, so after it loses 1 electron, okay, so now we end up with lithium, okay, left with 2 electrons, and then the positive charge, okay, it forms a positive ion. Hydrogen receiving 1 electron, okay, from the lithium. So now it's negatively charged, okay, like this. Okay, so this is the dot and cross diagram of the lithium hydride. Okay, okay, so if we do it correctly, it's just like that. Okay, yep. Okay, explain the difference in the Pauling electronegativity values between O and S. Okay, so O and S, okay, like this. Okay, so let me copy. Okay, okay, why the oxygen and sulfur, they have different electronegativity values. Okay, so in the periodic table, okay, so oxygen is here, sulfur is here. Okay, so oxygen, okay, oxygen is 8, sulfur is 16. Okay, okay, 8 and 16. Okay, so the electron configuration, okay, 1s2, 2s2, 2p4. Okay, okay, so this one will be 1s2, 2s2, 2p6, and then 3s2, 3p4. Okay, like this. Okay, now sulfur will be like this. Okay, 2, 8. Okay, 6. Okay, and then oxygen will be, okay, 2, 6. Okay, so the electronegativity, it depends on the nuclear charge and the radius. Okay, so which one is having a higher nuclear charge? Sulfur. Okay, sulfur is having a higher nuclear charge, which is 16. Okay, 16 proton. Oxygen is 8. Okay, so suppose we can say sulfur is having a higher nuclear charge it can attract more electrons, okay? It can attract electrons more strongly, okay? But in reality, sulfur is having lower electronegativity. It's lower. Why? Then this is the effect of the radius, okay? So sulfur, the outer electron, they are in the third shell, okay? They are in the third shell, but oxygen, they are in the second shell, okay? So for oxygen, it's closer to the nucleus. For the sulfur, it's further away from the nucleus. So that's why, okay, the attraction of the nucleus is less. So that is the main reason, okay? Yep. Okay, so the oxygen is having lower nuclear charge, but is having less shell than sulfur, okay? So oxygen is shell number 2, sulfur is shell number 3, okay? So because it has fewer shell, it has a greater attraction in oxygen for the electrons. So that's why oxygen is having higher electronegativity values, okay? Yep. So both will play a role. Nuclear charge and the radius, okay? And the distance. In this case, the distance is more significant, okay? How far away the electrons from the nucleus is playing a more important role here. Okay, you see, define electronegativity. So it gets repeated a lot, this question. Okay, power of atom to attract electrons to itself. Okay, complete the dot and cross diagram to show the bonding, okay, of Al2Cl6. Okay, yeah. So this one is, as you will see later, this question is also repeat a few times over the last few years. Okay, so we just need to like remember how to do that. Okay, so yeah. Okay. Okay, so excuse me. Basically, it's like this. Okay, so yeah. So we just need to make sure we know what is going on. Okay. Uh, okay. So first, we just need to know how to draw AlCl3. Okay, AlCl3 is just the we have the covalent bonding. Okay, just a standard covalent bonding between aluminum and chlorine. Okay, so we have the standard covalent bonding, and then kind of like this. Okay, Cl. Okay, covalent bonding like this. Okay, and then we need to do draw two of them, and then we draw the okay the coordinate bonding. Yeah, okay, like the lone pair from the chlorine will donate to the aluminum, okay, of the other AlCl3. Okay, yeah, so basically that's the main point. So we just need to make sure um we understand what is going on. Okay, so you see all of these, both sides contribute the electron. Okay, both sides. But this one, the coordinate bonding, is only coming from chlorine. Okay, and then aluminum, because it has uh it has only 6 electron on the outside, so it still has one empty orbital to receive the extra electron. So that's why it can receive the 2 electrons from chlorine. Okay, yeah, so these are the main points. So we just need to make sure we are not confused. Okay, when we come to drawing the two molecules. So the easiest way to draw the two molecules separately, and then we need to know where the coordinate bonding happens. Okay, and then the coordinate bonding, we must remember, is only coming from one atom. It's not electron sharing. Okay, is one atom contributing both of the electrons. In this case, is chlorine. Okay. Okay, ionic and covalent bonds both involve an electrostatic attraction between different species. Identify the species that are electrostatically attracted to one another. Okay, so this is quite a fine point. Okay, so in IGCSE, we just need to know it is attraction. Okay, ionic bonding, they have attraction. That's why they form a bond. Covalent bonding, they have attraction. That's why they form a bond. But we do not learn about specifically is the attraction between what. Okay, is the attraction between what. Okay, so it's not the same. Okay, so example, we have ionic bond, let's say between sodium and chloride. Is the attraction between the ions. Okay, between the ions, positive and negatively charged ions. Okay, yes, oppositely charged ions, cations and anions. Okay, how about covalent bond? Okay, covalent bond. Okay, let's say we have HCl. Okay, something like this. Okay, so 1, 2, 3, 4, 5, 6, 7, and then like this. Okay, so what is a covalent bond? Okay, covalent bond, we see there are no ions. Okay, so it's not attraction between ions, is the attraction between this. Okay, chlorine nucleus, it has protons. Okay, it has 17 protons there. Okay, the protons are positive, and then the hydrogen, it also has 1 proton. Okay, this the attraction between the positive nucleus. Okay, yeah, so we go into a lot of detail. The attraction between what? We need to be clear about that. Okay, so for a covalent bond, is the attraction between the positive nucleus and the electrons. Okay, and then this one is also between the positive nucleus and the electrons. Okay, so in both cases, it's attraction between positive and negative. Here is also between positive and negative, but this positive and this negative not the same. This one positive ion and negative ion. This one is positive nucleus and negative electron. Okay, so this both positive, negative, but the positive species and the negative species not the same thing. Okay, so here, okay, it's between the shared pair of electrons. Okay, this shared pair of electron and the two nucleus. Yeah, okay. So it's positive, negative attraction, but it's not the same thing. Yeah, okay. Not the same thing. We need to be clear about that. Okay. So this is also quite recent question, November 2022. Okay. Okay. Okay, draw a label diagram showing the bonding in magnesium metal. Okay, so you can see it gets repeated a lot. Okay. Okay, just the metallic bonding. So we just need to remember how to draw the metallic bonding, the giant metallic lattice. Okay. Yeah. Okay. Okay. Draw and cross diagram to show the arrangement of um RaCl2. Okay. RaCl2. Okay. Radium Ra is found in group 2 of the periodic table. Okay. Hold on. Okay. Yeah. Okay. Radium. Okay. Here. Okay. Radium is here. Okay. It's in group 2. Okay. Okay. No problem. Um. Okay. Radium chloride RaCl2 has a melting point of 900 degrees Celsius and is soluble in water. Predict the lattice structure of RaCl2 based on the properties described. Okay, so this one is between metal and non-metal. Okay, Ra is a group 2 metal. Between metal and non-metal, okay, we will form ionic bonding. Okay, ionic bonding. Okay. Okay, so here we not only need to say about ionic, we also need to talk about the lattice structure. Lattice structure is giant lattice structure. So means it forms millions and millions of ions joined together. Okay, it forms a giant structure. Okay, draw a dot and cross diagram to show the arrangement of outer electrons in the radium. Okay, radium Cl2. Okay, so radium, we know that is in group 2. So we are starting with two outer electrons. Okay, so we are starting with two outer electrons. Okay, chlorine. Okay, chlorine, they have group 7. Okay, so 7 outer electron. Okay, two of them. Okay, 7 outer electron. Okay, now, okay, radium, it wants to form a full shell, so it will lose the 2 electrons on the outside. Okay, so after it lost the 2 electrons on the outside, okay, so it will form radium 2 plus. Okay, and then the chlorine, receiving the electrons from the radium. Okay, receiving electrons from the radium. Okay, okay, hold. Okay, receiving 1 electron from the radium. Okay, in addition to the electrons they have at the start. Okay, the 7 electrons they have at the start. Okay, so receive 1 electron from -1. Okay, and -1. Okay, so this is the dot and cross diagram of this ionic compound. Yeah, okay, like this. Okay, 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 we start here. Okay, hydrogen iodide is a colorless gas at room temperature. Explain why hydrogen iodide has higher boiling point than HCl than HBr. Okay, okay, Cl, Br, I. Okay, in the periodic table is arranged like this. Okay, okay, so Cl, if we look at the periodic table, hold on. Okay, periodic table, a okay, 17, 35, 53. Okay, 17, 35, 53. Okay, okay, so it's telling us this is the proton number. Okay, which equal to the number of electrons. Okay, 17, 35, 53. Okay, so you see, iodine is having so many electrons. Okay, so we know that. Okay, so actually HCl, HBr, HI. Okay, they can, these are polar bonds. Okay, so these are all polar bonds. So they can have PD. Okay, they can have permanent dipole. Okay, they can also have the induced dipole, instantaneous dipole. Okay, so which one is affecting the boiling point? Which one is affecting the boiling point? Is it the PD or is the ID in this case? Okay, so if it is the PD, okay, if it is the PD, in this case they are pretty much uh almost similar. Okay, so which one is going to have a stronger PD? Okay, which one has a stronger dipole? Okay, the one that have a stronger dipole will be a, okay, let us check. Okay. Okay, let's explain one time clearly this one. Okay. So this one is the um okay, electronegative. Okay, electronegativity values. Okay. Okay. So FClBri. Okay. So if we look at the trend, the electronegativity, okay, it should be decreasing. Okay. So this is 4, 3, maybe like 2, 1, something like that. Okay. So it should be decreasing. Okay. It should be decreasing. Why is decreasing? Because for the iodine, okay, so FClBri. Okay. So the radius is not the same. Okay. Okay. Cl. Okay. Bri. Okay. So the radius is getting bigger. Okay. Okay. Because this is period 2, period 3, period 4, period 5. Okay. So the radius is getting bigger and bigger. And then the outer electron is further away. Okay. So we can see the outer electron is further away from the nucleus. Okay. So when the outer electron is further away from the nucleus cannot attract the electron. Okay. It's very difficult to attract the electron. So that's why the electron negativity is getting less and less. Okay. So now if we compare, okay, the PD permanent dipole, okay, HCl, HBr, okay, Hi, which one is having a stronger dipole? Okay. Okay, this one, it will be the strongest dipole because this chlorine is like 3, 1. Okay. This is like maybe 2, 1. This is maybe like 1, 1, something like that. Okay. So the electronegativity difference is the strongest. Okay. So this one, it will be having the strongest dipole. Maybe like this. Okay. This one will be a smaller dipole, and then this one will be the smallest dipole. Okay. If we think about the PD effect, okay, which one is stronger? The chlorine is stronger. Okay. The chlorine is stronger. So means the chlorine will be having the highest boiling point. We predict. Okay. The chlorine is having the highest boiling point. But in reality, okay, when we do the experiment, when we check the boiling point, in reality, the Hi is having the highest boiling point. Okay. The iodine one is having the highest boiling point. Why? Okay. Why? Because in this case, the PD effect is not as strong as the ID effect. Okay. In this case, the ID effect is stronger. Okay. ID, it depends on what? ID, it depends on how many electrons. Okay. How many electrons? Which one is having more electron? Iodine. Okay. So iodine is 53 electron. Br is 35. Chlorine is 17. Okay. So iodine is having more electron. Okay. So when it has more electron, the ID is stronger. Okay. So when the ID is stronger, it has higher boiling point. Okay. So that's how we explain it. Okay, so it's very easy to confuse because they have both PD and ID. Which one is affecting the boiling point? Okay, both can affect it. But in this case, based on our measurement, we find that the iodine, okay, the iodide is having the highest boiling point, which is telling us the ID is having the stronger effect here compared to PD. Okay, yeah. So this is a very key point to understand. Okay, so you see here why? Because the iodide is having a greater number of electrons, so it will have a greater induced dipole. So it will have a stronger intermolecular forces. Okay, stronger intermolecular forces. So it's going to have a higher boiling point. Okay, so if we refer back to our notes, we did discuss about that. Okay, briefly. Okay, yes. Okay, instantaneous dipole. Okay, temporary dipole. It depends on what? Okay. Okay, it depends on the number of electrons. Yeah, okay. The number of electrons present, because the more electrons the molecule has, the larger the chance for instantaneous dipole is likely to be. Okay. When it has more electron, it can have a bigger dipole. Okay. So, and then other things like molecular shape also have effect. Yeah. So we can see here comparing. Okay. Fluorine, chlorine, bromine. So the bromine will be having the highest boiling point because the number of electron increases. Okay. Okay. Right. Okay. Carry on. Okay. CS2 is a liquid under room condition. CO2 is a gas. Okay. Explain what causes the difference in the physical properties between CS2 and CO2. Okay. So CS2, the structure is like this. Okay. It's linear. Okay, linear because there is no lone pairs on the carbon. Okay, CO2, they are also linear. Okay, they have polar bonds. Okay, they have dipoles like this. They have polar bonds, but okay, but they cancel out. They cancel out because of the symmetry of these two molecules. Okay, so they cancel out. So we are saying that they are both non-polar. Okay, so they are both non-polar, means they have ID only. Okay, so they only have ID. They don't have the PD. They don't have the hydrogen bonding. Okay, they don't have. They only have ID. So if they only have ID, what is the thing that affect the boiling point? What's the thing that affect the boiling point? Electrons. Okay, electrons. So oxygen and sulfur. Okay, oxygen is 8, sulfur is 16. Okay, so sulfur is having more electron. So that's why it's going to have a stronger ID intermolecular force. So it's going to be higher boiling point. Okay, so that's the idea. Yep. Okay, having more electrons, stronger induced dipole forces between the molecules. Okay, yeah. Okay, anything not clear, you just stop me. Okay. Bond angle in molecule of CS2. Just now we mentioned it is linear, so it will be 180. Yeah, 180 degree, the bond angle. Okay. Dot and cross diagram of the CS2. Okay. So carbon is period 2, so it cannot have expanded octet. So it just can have a maximum of 8 electrons. Okay, so carbon is group 4, so we are starting with 4 electrons. Okay, 4 electrons. Okay, sulfur is in group 6, So we are starting with 6 electrons, okay? 6 electrons, like this. Okay, so carbon, it got 4 electron. Okay, it needs to form 4 bonds, okay, to get the octet, okay? So sulfur, it has 6 electrons. It just need to form 2 bonds to get the octet. Yeah, okay. So the most ideal way to fulfill these two conditions is to have this. Okay. So now carbon forming 4 bonds, sulfur forming 2 bonds, and then uh the unbonded, okay, lone pairs still remaining like this. Okay. So to draw the proper dot and cross diagram, it will be like this. Okay. So we have the carbon. Okay. Okay. So the carbon is having 4 electrons to start with, and then the sulfur having 6 electrons. Okay. It only need to form 2 bonds. So like this. Okay. It only need to form 2 bonds. Okay. So we end up having this structure here. Okay, state the meaning of volatile, not important. Okay, easily vaporize. Okay. Okay, next. Okay, nitrogen. Okay, maybe better we start here. Yes. Okay, carbon monoxide gas, okay, and nitrogen gas, they are both diatomic molecules. The diagram shows the arrangement of outer electrons in a molecule of carbon monoxide, no problem. State one similarity and one difference in the way the atoms in carbon monoxide molecule are bonded together compared to the nitrogen. Okay, so nitrogen is like this. Okay, nitrogen also form triple bond. Yeah, okay. Nitrogen also form triple bond. So nitrogen atom group 5, 5 outer electron. Okay, so 5 outer electron. Okay, it need to form 3 bond. Okay, so which means it's sharing 3 electrons. Okay, sharing 3 electrons. 1, 2, okay, 1, 2, 3. Okay, and then here also sharing 1, 2, 3. So now it ends up with the octet. Okay, so what are the similarities and differences? They are quite similar. Okay, uh, similarity, they both make triple bond. Okay, 3 shared pair of electrons. Okay, um, okay, so for CO, one bond in CO is coordinate, is dative bond formed by donating a pair of electrons from oxygen to carbon. Okay, so yeah. So what does that mean? Okay, so carbon, we are starting with 4 electrons. Okay, 1, 2, 3, 4. Okay, so oxygen, we are starting with 6 electrons. Okay. Okay, so what is the best way to uh to make sure that both of them get the octet? Okay, so carbon is 4 electrons, it needs to form 4 bonds. Okay, so oxygen, okay, it got 6 electron, it needs to form 2 bonds. Okay, so what do we start with? Okay, okay, so we start with, okay, carbon forming um 2 bonds. Okay, so oxygen, it wants to form 2 bonds. Okay, oxygen, it wants to form 2 bonds, so it will put 1, 2, 3, 4, 5, 6 like this. Okay, so carbon, it wants to form 4 bonds. Okay, but oxygen, it cannot form 4 bonds. Okay, if it form 4 bonds, it will be too many electrons. Okay, so carbon will be like this: 1, 2, 3, 4. Okay, so now the oxygen already have octet, but carbon is not octet. So what do we do? Okay, so the last pair of electrons is coming from oxygen. Okay, going into the middle. Okay, so to give us this situation here. So now both of them is octet. Okay, so the last bond is actually a dative bond. It's a coordinate bond. So that is the difference between nitrogen and carbon. Okay, both triple bond, it looks very similar, but the um actual type of bond is slightly different. Okay, okay, let me check. Did we miss anything? Hold on. Oh, okay, we did miss out one question here. Okay, just now. Hold on. Okay, this one. Okay, we forgot to do this. Okay, so here we have HCl, HBr, and Hi. Okay, HCl, HBr, and Hi. Okay, so just now we already discussed Hi is having the highest boiling point because of the ID. It has more electrons. Okay, more electrons. So the ID force is stronger. So the boiling point is highest for the hydrogen iodide, no problem. Okay, how about HF? Okay, HF, if we follow this trend, HF should be lowest boiling point because it has the lowest number of electrons. Okay, suppose it had should be having the lowest boiling point, but in reality, okay, hydrogen fluoride is highest. Okay, why? Because hydrogen fluoride can form hydrogen bonding, which is stronger than this ID force. So that's why, okay, hydrogen bond forms between HF molecule. Draw a bar on the chart to predict the boiling point of HF. Okay, so we predict HF will be the highest, even higher than the hydrogen iodide. Okay, explain your answer. Why? Okay, as we mentioned just now. Okay, so the bar of HF should be above the hydrogen iodide. Why? Because the strength of the hydrogen bond will be stronger than the induced dipole, the ID. Okay, so that is the main point there. The hydrogen bond is the strongest of all. Okay. Yep. Okay, coming back to our question here. Carbon, nitrogen, oxygen. Okay, so we are given the electronegativity values. Okay. Uh okay. So now for the N2 and CO, we need to work out the number of electrons per molecule. Okay. So nitrogen, if we look at the periodic table, 7 proton, so 7 electron. Okay. And then we have 2 nitrogen will be 7 plus 7 equals to 14. Okay. So carbon, if we look at the periodic table, 6 proton, 6 electron. Okay. Oxygen, 8 proton, 8 electron. Okay. 8 plus 6 equal to 14. Yeah. Okay. Yep. Okay. Yeah. So they have the same number of electrons. Okay. They have same number of electrons, but they have different type of intermolecular forces. Different type of intermolecular forces. Why? Because nitrogen is non-polar. Okay. Nitrogen is non-polar. Mm, okay. it only have ID. Okay. CO is polar. Okay. Oxygen is more polar than carbon. So the dipole is towards the oxygen. Okay. So this will have ID and also permanent dipole. Okay. Both. Okay. So this is what we need to talk about here. Okay. So the nitrogen is only having instantaneous dipole or induced dipole. Okay, so CO will be having permanent dipole as well as induced dipole. Yeah, okay. So it has both. Okay. N2 is less reactive than CO, even though N2 has a lower bond energy than CO. Suggests why CO is more reactive than N2. Okay, so the main point is this. Okay, because it's a polar molecule. Yeah, okay. It has a permanent dipole, so it's easy to interact with other molecules because it has a partial charge. Okay, so it has a partial charge. It's easier to interact with other molecule. So that's why CO, we expect CO to be more reactive. Okay, more reactive than nitrogen. Okay, make sure we haven't missed any questions. Okay. Okay. Describe what you would see when aluminum chloride reacts with water. So this one is not that important. It's later chapter. We just go through quickly. Okay, it will disappear from the steamy film, temperature increase. It's a hydrolysis reaction. Yeah. Show all the type of bond present in Al2Cl6. Okay, so you can see it starts to repeat the question. Yeah, okay. So we have the covalent bond and then we also have the coordinate bonding. Okay, so we need to show that. Okay, describe the structure of silicon oxide. Okay, so we know that silicon oxide is yes, here. Okay, silicon oxide is giant covalent. Okay, giant molecular lattices. Okay, yep. Hold on. Yep, giant covalent. Okay, and the tetrahedral arrangement of the atoms. Okay, because each silicon it has four outer electron. Okay, four outer electron, so it will form four bonds to obtain the octet. Okay, so it will form this tetrahedral arrangement. Okay, of the atoms. Okay. So we need to make sure we have all the key points there. Okay, so the word giant is important because it is a giant structure, millions and millions of atoms joined together. Okay, hold on. Okay, describe metallic bonding. So this is also very straightforward. Okay, lattice of cations, positive ions surrounded by delocalized electrons. Okay. Okay, next. Lithium hydride contains ions of lithium and hydride. State the electronic configuration of these two ions. Okay, so we start with the lithium atom. Okay, zero oxidation state, and hydrogen atom, zero oxidation state. Okay, if we look at the periodic table, proton is 3, electron is 3. So electronic configuration is 1s2. Okay, 2s1. Okay, so is 2 1. Okay, electronic configuration. So hydrogen atom. Okay, one proton, one electron. So it's just 1s1. Okay. So the electronic configuration is just 1. Okay. So lithium atom, to form the full shell, it will lose the outer electron. Okay. So lithium, okay, it will lose the outer electron to the hydrogen. Okay. Lose the outer electron to the hydrogen. So in the end, okay, it's just 1s2. Okay. So the final electron configuration is just 1s2. Lost this electron there. Okay. Okay, it's just 1s2. Okay. How about the hydrogen? Okay, so you see it received one electron from the lithium. So now it becomes two electrons. So which means it turns to 1s2. Okay. So the electron configuration, it becomes like this. Okay. Yep. 1s2 and 1s2. Okay. State the bond angle of AlCl3. Okay. So the aluminum chloride, it can be in two forms, AlCl3 or Al2Cl6. Okay. So it can be two-way. Okay. But when the temperature is very high, it will break down. It will break down into AlCl3. So AlCl3 is just like this. Okay. Trigonal planar. Okay. Trigonal planar. So the bond angle is just 120. Okay. It's just 120. Okay. Okay. So this one, it repeats again the question. Draw the structure of Al2Cl6. Show fully the coordinate bonding. Okay. Yeah. So you see the questions, they repeat. Okay. Same kind of question. Okay. So this one is also like kind of questions that involve another topic. So we just um roughly, okay, we go through it roughly. Okay. Element E is a period 5 element. Okay. It reacts with oxygen to form insoluble white oxide that has melting point of 1910. Okay, the oxide conduct electricity only when liquid. So it's telling us this is a ionic, okay, ionic compound. Okay, yep. Okay, it's ionic compound. Ions are only available when it's in liquid or molten form. Okay, so this is characteristics of ionic compound. Okay, and then um, so which telling us element E should be a metal. Okay. So secondly, it react with chlorine. Okay. It react with chlorine, but it form a white solid that react exothermically with water. The resulting solution react with aqueous silver nitrate to form white precipitate that dissolve in dilute ammonia. Okay, dissolve in dilute ammonia. So means this is acidic compound. Okay, because it's acidic compound, it can react with ammonia. Okay, so it form acidic compound. So means element E, it also have a non-metal characteristic. Okay, because it can form acidic compound. Okay, normally metal, it will form like salts or um basic compound. But if it's acidic, means it got non-metal characteristics. Okay, so that's what we are talking about here. So we are saying that this one is covalent. Okay, it's hydrolyzed by water. Okay, so if we are saying that this element E is metal, so how come it got the non-metal characteristics? Okay, so we suspect uh is somewhere here. Okay, so this is our boundary. Okay, between metal and non-metal. So period 5. So which means that it's somewhere around here. Okay. So they have both metal and non-metal characteristics. Okay. So this one we will learn in later chapter. So at this moment, we don't concern too much. Okay. Okay. Dot and cross diagram of Cl2O. Okay. Cl2O. Okay. So we can see oxygen is the central atom. Okay. Oxygen is the central atom. Okay. Oxygen is in period 2. Okay. So it cannot have the expanded octet. So maximum 8 electrons. Okay. So oxygen has 6, okay, outer electrons. So it needs to form 2 bonds. Okay. Chlorine, okay, 7 outer electrons. Okay. 7 outer electrons. So it forms 1 bond only. Okay. So which means, okay, how it works, we got the oxygen. Okay. 1, 2, 3, 4, 5, 6. Okay. Forming 2 bonds. Okay. Chlorine like this. Okay. So chlorine will be forming 1 bond only. Okay. 1 bond only. Okay. So this is the way to arrange it so that we get octet for both of them. Okay. So it should be like this. Okay. So if we do everything correctly, it will be like this. Okay. Okay, next, electronic configuration of copper atom. So this one is last chapter. So it's not this chapter, it's last chapter. So this one okay, we don't go through it. So I just show the answer. Okay, I just show the answer. So in case anything not sure, we can discuss. Okay, so this is the answer. Okay, draw a label diagram to show the bonding within a sample of solid copper. Again, same thing. Okay, metallic bonding. We just need to show the metallic bonding. Okay, type of bonding. Okay, metallic. Okay, describe and explain the trend in thermal stability of the hydrogen halide. Okay, yeah. So just now we mentioned about this. Okay, okay, wait. Okay, hydrogen halide are useful reagents in organic and inorganic reactions. Okay, hold on. Okay, describe and explain the change in boiling points of the hydrogen halide. Okay, so as we mentioned before, okay, hydrogen, okay, Hi. Okay, going down the group is increasing boiling point. Increasing boiling point. Why? Because it's increasing ID. Yeah, increasing the instantaneous. Okay, increasing the ID. Okay, why increasing ID? Because increasing electrons. Okay, increasing number of electrons. Okay, yeah. So that's the main point. Okay. The boiling point will be increasing down the group because increasing the instantaneous force. Why? Because increasing number of electrons. Okay. Describe and explain the trend in thermal stability of the hydrogen halide. Okay. So this one is it's not this chapter, it's another chapter, but we can go through quickly. Okay, so it will be less stable down the group. Okay, less stable down the group. Okay, why? Because lower bond energy. Okay, so we'll try to explain this. Okay, we'll try to explain this. Okay, let me just find the picture quickly. Okay, what is going on there? Okay, what is going on? Okay, yes. Okay, yes. Okay, Okay. So this one, when we're talking about boiling point, okay, when we're talking about boiling point, we are breaking the intermolecular forces. Okay, we are breaking the intermolecular forces. But when we are talking about thermal stability, we are breaking the covalent bond. Yeah, it's different thing. Thermal stability, okay. So this one, we are looking about how strong is the intermolecular forces. We are concerned about intermolecular forces. Okay. But for the thermal stability, we are concerned about, we actually want to break this bond here. Okay. We want to break the covalent bond. Okay. We want to break the covalent bond. Okay. So which one is a stronger covalent bond? Okay. So our answer is Cl. Okay. Thermal stability, if going down the group, will decrease. Okay. Decrease thermal stability. Okay. Decrease thermal stability, which is telling us this bond is easier to break. Okay. It's easier to break the Hi bond. Okay. Why? Because uh, going down the group, the bond is weaker. Okay, the covalent bond is weaker. Okay, why the covalent bond is weaker is, okay, so this is the reason. Okay, Cl, okay, Br, okay, I is to do with the radius. Okay, is to do with the radius. Okay, okay, so hydrogen is like this. Okay, okay, hydrogen is like this. Okay, so the bond strength, it depends how close they can get. Okay, so we can see this one is a longer bond, so it is also a weaker bond. Okay, so this one is a shorter bond. A shorter bond is also a stronger bond. Yeah, okay. So that's why we are saying less stable down the group. Going down is a weaker bond, so it's less stable. Lower bond energy, okay? So this is lower bond energy. So it's easier to break the bond, okay? And then another explanation. What is another explanation? Okay, you see, this one, the outer electron is far away from the nucleus. Okay, this outer electron is close to the nucleus. Okay, when the outer electron is close to the nucleus, it's easier to attract. Okay, so this covalent bond is stronger. Okay, easier to attract the bond, the electron in the covalent bond. So this covalent bond is stronger. You see, this electron is so far away from the nucleus, it's very difficult to attract it. So that's why this bond is weaker. Okay, so that's the reason. This one we will learn more in later chapters. Okay, next. Okay, um, excuse me. Chlorine react with tin metal to form tin chloride. Okay, like this. Tin chloride is a colorless liquid at room temperature that react vigorously with water to form acidic solution. No problem. The type of structure and bonding shown by tin chloride. Okay, so this one react vigorously with water to form acidic solution. This is telling us it is covalent. Okay, only covalent compound will form acidic solution. Okay, so if it's a covalent, because it's not giant covalent, it's just simple molecule with 5 atoms. Okay, so this one we are saying that this is a simple covalent. Okay, simple molecular structure because it has low melting and boiling point, and then because it can form it can be hydrolyzed. Okay, it can react with water to form acidic solution. Okay, so this part we will learn in later chapters. Okay, describe the coordinate dative bond in this molecule. You see, this AlCl6, it comes again. Okay, it keep coming, the same question. Okay, how the coordinate bond form? Okay, the iodine donate the pair of electron to the aluminium. Okay, yep. So normally we have Cl, Cl, Cl. Okay, we have Cl iodine. Okay, so iodine and Cl is in the same group. So the chemical properties is the same. So we replace iodine with chlorine. It forms the same carbon. Okay, how many coordinate bonds? Okay, we know is two. Okay, it's just two. Okay, because the aluminium, it can accommodate two more electrons only. Okay, so it's just two coordinate bonding. Okay. Okay. Uh, okay. List all the forces of attraction present in solid iodine and identify which of these are overcome when solid iodine is heated to produce iodine vapor. Okay. So iodine, okay, like this. Okay. So this is the iodine. So it got two type of attraction. Okay. So it got the covalent bond. Okay. Covalent bond. And then it also have the, okay, intermolecular forces. Okay. So it also have the intermolecular forces. Okay. Intermolecular forces, it only have ID. Okay. Because it is non-polar. Okay. So only ID. Okay. In solid iodine, identify which of these are overcome to produce iodine vapor. Okay, so this one is for boiling. Okay, so boiling, we are only breaking the intermolecular forces. Okay, so what we are saying, it has two type of forces. Okay, two type of forces. We have the covalent and also the induced dipole. Covalent and induced dipole. But for boiling purpose, we are only breaking the induced dipole. Okay, the covalent bond still staying there. Okay, so that's the key point we need to be careful. Okay, iodine is element in group 17 in the periodic table. Okay, at room temperature, iodine solid has a lattice structure. Okay, describe the arrangement of the iodine molecules within the solid. Okay, yeah. So this iodine, it can present as gas, liquid, okay, and solid. Okay, it's kind of like water. Okay, so water can present as gas, liquid, and solid. Okay, so when it is in the solid state, like example, water in solid state is ice. Okay, so ice is not like when it's gaseous form. When it's gaseous form, the water molecules is just free to move anywhere. Okay, but it's in solid state, it's just fixed. The position is fixed. It cannot move easily. Okay, so the arrangement is a standard arrangement in a solid, held in regular uniform arrangement. Okay, so we just need to answer like this. Okay, yes. Yeah. Okay, we just need to answer according to this. Okay, fixed regular three-dimensional lattice. Okay, can only vibrate about fixed position. Okay, that's all we need to answer. Okay. Okay, next. Explain why methane has no overall dipole moment. Okay, so methane is like this. Okay, four group of electrons. Okay, four pair of electron in a tetrahedral arrangement. Okay, tetrahedral arrangement, which is symmetrical. Yeah, okay. So it's highly symmetrical. So there is no dipole moment. Okay. Yeah. Okay. So tetrahedral molecule, the individual dipoles or the partial charge, they cancel out. Okay. Because of the symmetry. Okay. CH and SH bond, they have weak dipoles. Okay. They have weak dipoles. Why? Because they have different electronegativity. Okay. So carbon is 2.5. Okay, hydrogen is 2.1. Okay, silicon is 1.8. Hydrogen is 2.1. Okay. So now the dipole will point towards the more electronegative atom. Okay, it will point toward the more electronegative atom. Okay. To show the polarity, okay, so basically we need to show the partial charge. Okay. So in here, the partial charge will be on the carbon because it's more electronegative. Okay. Partial positive will be on hydrogen. And then here, because hydrogen is more excuse me, is more negative. So delta negative will be on hydrogen, delta positive on silicon. Okay. So this is what we need to answer. Okay. Yep. Okay. Okay. So okay, so this part I haven't prepared yet, but it's okay. We just carry on. Okay, this one. Magnesium silicide is a compound made by heating magnesium with sand. Okay, magnesium silicide. Draw a dot and cross diagram to show the arrangement of outer electrons present in a formula unit of magnesium silicide. Okay, assume it is a ionic compound. Okay, assume it is ionic compound. Okay, we only want to show outer electrons. Okay, so magnesium is group 2. So magnesium is group 2. It's got 2 outer electrons. Okay, so it's got 2 outer electrons. Okay, magnesium like this. Okay, Mg2. So we got 2 magnesium. Okay, so silicon is in group 4. Okay, so silicon in group 4. So it has 4 outer electrons. Okay, so 4 outer electrons. Okay, so magnesium, to form the octet, it will lose the 2 outer electron. Okay, so it will lose the 2 outer electron. Okay, so this magnesium also will lose the 2 outer electron. Okay, so what happened? We end up with the magnesium lost the outer 2 electron and then form the 2 plus. Okay, lost the outer electron. Okay, form the 2 plus. Okay, what happened with the silicon? So the silicon, okay, it start with 4 electrons, and then now it receive 4 electrons from the magnesium. Okay, so now we end up with silicon with a 4 plus negative charge. Okay, so this is what we expect to answer. Okay, okay, let me check the answer just in case. Okay, hold on. Okay, let me check the answer just in case. Okay. Um, here. Okay. Yep. Okay. So this is what we need to answer. Okay. Mg 2 plus and then like this. Okay. Silicon like this. Okay. So this is the correct answer. Okay, which we got it. Okay. Yeah. Okay. When this solid here added to water, silane gas, and solution of magnesium hydroxide is produced. Construct the equation for this reaction. Include state symbol. Okay. Yeah. So this one we need to like learn later topics to understand more about this. So for now, we just quickly will the answers. Okay. We just quickly look at the answer. Okay. Okay. Yeah. Okay. So this one is just telling us that this is actually ionic compound. Okay. This is metal oxide. Okay. Metal compound. It react with water. It will form basic. Okay. Solution. But if we have like covalent compound, it react with water, it will form acidic, as we mentioned just now. Okay. So this one we'll learn in later topic. Okay. Why SiH4, okay, is a gas at room temperature. Okay. With the structure and bonding, why H4 is a gas at room temperature. Okay. Because it is a simple covalent compound. Okay. So simple covalent compound and then with intermolecular forces. So basically it just can be a gas at room temperature. Ah, yes, yes. Okay. So this is our explanation. Okay. Yep. Okay. Like SiO2, like for example, SiO2, this one is giant covalent. Okay. So giant covalent. So this one will be um uh high melting point. Okay. High melting point, high boiling point. Okay. This one is the gas at room temperature, low boiling point, because it's a simple covalent compound, okay, with weak intermolecular forces or okay, temporary dipole, okay, induced dipole. So that's why it has a low boiling point. Okay. Okay. Yep. Next. Okay. Okay, we start here. Okay. So we are given a few compounds, elements in group 17. They are called halogen, form stable compounds of both metal and non-metals, no problem. Okay, state what is meant by relative formula mass. Okay, so this is also like from the first chapter. Okay, so we just go through it quickly. Okay. So basically this one we need to memorize this definition. Okay. So first we need to say that it's the mass of a molecule. Okay. Okay, it's a mass of a molecule. Okay, so this is the first point there, mass of a molecule. And then the second key point is compared to the mass of atom, carbon 12. Okay, compared to the carbon 12. So that's the definition. Okay, so we just need to memorize that to get the full marks. Okay, F2 and HCl, they are both covalent molecules. Okay, suggests why HCl is having a higher boiling point than F2. Okay, so we know that because F2 it is a non-polar molecule. Okay, so it only has ID. Okay, ID. But HCl is a polar molecule, so it got both ID and PD, permanent dipole. Okay, so that's the main reason there. Yep. Okay. Okay. Yep. So this is the explanation that we can give. Okay, so HCl has permanent dipole and also induced dipole, but fluorine, it only has induced dipole. Okay, so that's why HCl is having higher boiling point. Okay, because it has stronger intermolecular forces. Okay, stronger intermolecular forces. Okay, explain why CaF2 has very high boiling point. Okay, CaF2. Okay, 2000 something. Okay, we know why, because it is ionic compound. Yeah, okay. So ionic compound has very high um boiling point. Okay. Oh, yeah, sorry. Just now I missed out this point. Okay. Wait. Okay, this one actually we need to add another point, which is okay. Okay. So we need to say that okay, HCl has permanent dipole and induced dipole. Fluorine has induced dipole only, and then we need to say that the HCl has a stronger intermolecular forces. Okay, it has a stronger intermolecular forces. That's why it has a higher boiling point. Okay, we need to add that point. Okay, another one. Okay, yep. Okay, this one. So why the CaF2 has a very high boiling point? Okay, so we are saying that because it's ionic compound. Okay, it's not enough to say that. We need to explain what is ionic compound. Strong electrostatic forces of attraction between oppositely charged ions. Okay, we need to explain what is the ionic compound. So that's why it has a high boiling point. Okay. Okay. CaF2 made by reaction of calcium carbonate and hydrofluoric acid. Write the equation, include state symbol. Okay, so this is very straightforward. Chapter 1. So we can just quickly go through that. Okay. Yep. Okay. Just like this. Okay. So we just need to make sure we know how to write and balance the equation and how to write the state symbol. Okay. Okay. This is done. Okay. Next one. Oh, yes. Okay. Describe the metallic bonding in gold. Okay. Can you see? It start to repeat again. So we just draw the metallic bonding and then the localized electrons, delocalized electron. Okay. Just like that. Okay. Draw the dot and cross diagram of a nitrogen molecule. Show outer electrons only. Okay. We know how to do that. Okay. So nitrogen, we start with 5 outer electrons. Okay. We start with 5 outer electrons. So it needs to form 3 bonds to get the octet. 3 bonds to form the octet. So for nitrogen, we know how it works. Okay. So it will form the triple bond. Okay, like this. Okay. And then hit like this. Okay. So basically it forms the triple bond. So now it fulfill the octet for both atoms. Okay. So that's how it works. Okay. On. Okay, another 15 minutes. We keep going for a bit. Okay, yeah. Okay, draw the diagram to show the shape of the molecule of each of these oxides. Okay, SO3 and Cl2O. Okay, name each shape. Okay, in SO3, each oxygen atom forms a double bond with the sulfur atom. Okay, so we think about that. Okay, so sulfur, okay, we are starting with 6 electrons. Okay, 6 electrons. Okay, so if each oxygen, okay, it form a double bond, it will be like this. Okay, okay, each oxygen form a double bond, it will be like this. Okay, 1, 2, 3, 4. 5, 6. 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4, 5, 6. Okay. So now we see all the oxygen have octet. Okay. No problem. Okay. Oxygen have the octet. But how about the sulfur? Sulfur is got 12 electrons. Okay. It got 12 electrons. But we know this is okay. No problem. Okay. We know this is okay. Why? Because sulfur is in period 3, so it's got the extra d orbitals. Okay. The d orbitals, so it can expand the octet. Okay. No problem. So now, okay, sulfur is like this. Okay. Sulfur is like this with no, okay, with no lone pairs. Okay. So with no lone pairs, so we should expect, okay, bond angle 120. So the geometry should be trigonal planar. Okay, should be trigonal planar. Okay, now how about oxygen? Okay, so oxygen, we are starting with 6 electrons. Okay, 6 electrons. 6 electrons, it only need to form 2 bonds. Okay, to get the octet. So it will form, okay, 2 bonds. Okay, with the chlorine. Okay, it will form 2 bonds with the chlorine. Okay, chlorine, it has 7 outer electrons. 1, 2, 3, 4, 5, 6, 7. So it only need to form um another 1 bond to get the octet. Okay, no problem. So 1, 2, 3, 4, 5, 6, 7. Okay, so all of them have octet now. Okay, it works out, no problem. Okay, so now how we draw the structure? Okay, oxygen, Cl, Cl, and then lone pair on the oxygen. Okay, so we have the lone pair on chlorine, but it does not affect the shape because it's not on the central atom. We don't concern about that. Okay, like even we have the lone pair on the oxygen, it doesn't matter. Okay, we only care about the central atom. Okay, we only care about the central atom. How many pair of electron around the central atom? So in this case, it will be bands or non-linear. Okay, yeah. Yeah, to show the shape of the molecule and name each shape. Okay, so let's check. Let's check our answers. A. Okay. Yep. So this one nitrogen, no problem. Yes, yes. Okay. So we got the correct answer. Okay. Yep. Okay. Yep. We got the correct answer. Okay. So we just need to know like how to analyze, okay, the situation to get the correct answer. Okay. Okay. All right. Okay. Next. Okay. Did we miss anything? Okay. No. Okay. Oh yeah. Okay. Uh okay. Draw the dot and cross diagram of the ammonium ion. Okay, ammonium ion. Okay, so we can start with the ammonia. Okay, so okay, nitrogen is 6 outer electrons. I mean 5 outer electron, group 5. Okay, 5 outer electron, it needs to form 3 bonds. Okay, to get the octet. Okay, hydrogen is 1 electron, so it needs to form 1 bond. Okay, 1 electron, it needs to form 1 bond to get the full shell. Okay, so okay, use cross for nitrogen. Okay, so nitrogen, okay, like this. Okay, 1, 2, 3, 4. Okay, and then like this. Okay, with 3 hydrogen. Okay, okay, and then like this. Okay, so how about ammonium? Okay, ammonium is when we have one proton comes along. Okay, one proton comes along which has no electrons. Okay, because it lose one electron to form the proton. Okay, it lose one electron. Okay, so this hydrogen actually has no electron. So this nitrogen will form the dative bonding. Okay, it will form the coordinate bonding. Okay, on the hydrogen. Okay, so finally, okay, so the final structure will be like this. Okay, nitrogen. Okay, 1, 2, 3, 4, 5. Okay, okay, like this. Okay, and then the hydrogen. Okay, and then okay, like this. Okay, so this hydrogen is the one that bring in the positive charge. So overall, we have this. Okay, positive charge. Okay, so that's the dot and cross diagram. Okay, and then this one is a coordinate bond. So both electrons coming from the nitrogen. Okay, so both electrons coming from the nitrogen. Okay, let's check our answer. Yeah, okay, like this. Okay, so same thing. Okay, yep. So both are acceptable. Okay, so this is the same thing. Okay, so the key point here, okay, the key point here, the coordinate bond. Okay, the two electrons, both electrons coming from nitrogen. Okay, coordinate bonding. Okay, now suggest the shape. Okay, so you see now this nitrogen. Okay, okay, what happened to this nitrogen? Okay, four group of electrons. Okay, around the nitrogen. Okay, with no lone pair. Okay, with no lone pair. So this one will be tetrahedral. Okay, with the bond angle 109.5. Yep. Okay. Yes. Okay. Tetrahedral 109.5. Okay. So this one is the correct answer. Hold on. Yep. Okay. Makes sense, huh? Okay. Next. Um. Okay. Okay. Calcium ethane dioate is formed when calcium react with ethane dioic acid. Okay, the compound contains one cation and one anion. Draw the dot and cross diagram of the cation present in the calcium ethanoate. Show all electrons. Okay, so the cation, so the calcium. Okay, so calcium. Okay, calcium. Okay, look at periodic table. Calcium is here. Okay, 20 proton. Okay, okay, 20 proton, 20 electron. Okay, so calcium will be like this. Okay, so the electron configuration will be 2882. Okay, okay, 2882. Okay, 2, 8. Okay, 8. Okay, 2, like this. Okay, so this is calcium. Okay, how about when it formed the cation? Okay, so when it formed the cation means it will lose the outer electron. Okay, so it will lose the outer electrons, so means we just left with 288. Okay, so calcium. Okay, 2, 8. Okay, and then 8. Okay. Okay, after losing 2 electron, we got the 2 plus. Okay. Yep. Okay. Yeah. So it's like this. Okay. 288 with the 2 plus charge. Okay. 288 with the 2 plus charge. Okay. Like this. Okay. Draw the display formula of the anion present in the calcium ethene dioate. Okay, so this part we will learn more in the organic chemistry. Okay, we'll learn more in the organic chemistry. So at this moment, we just know it's look like this. Okay, it looks like this. Okay, yep. So the dioate ion, it looks like this. Okay, yep. Okay, a okay, dot and cross diagram of SiCl4. Okay, so I think this one can be the last question, SiCl4. So Si, we are starting with 4 outer electron. Okay, so 4 outer electron. So it needs to form 4 bonds. Okay, so chlorine is 7 outer electron. Okay, 7 outer electron. So it needs to form 1 bond only. Okay, so how it works is like this. Okay. Okay. Okay, so we are starting with the 4 electrons from the silicon. Okay, and then 7 from the chlorine. Okay, okay, 7 from each chlorine. Okay, yeah, like this. Okay, so 7 from each chlorine. Okay, um, yes, so basically just like that. So if we do everything correctly, all of them have the octet. Okay, so all of them will be having the octet. Okay, which is like this. Okay, yep. Okay, I think it's almost 6 o'clock, so I think we can stop here. So we done until page 25. So which means we have um we done 15 pages. We done around 15 pages. We still have around like 25 pages. Okay. So a okay, according to our plan, okay, so we done 3 classes so far. Okay. So we still have another 2 tomorrow morning and tomorrow afternoon. Okay. So if you feel like you are okay with the topic, we can cancel the 2 class tomorrow. Okay. We just stop here. But if you feel like you need more, okay, you need to go through more questions together, like the multiple choice and also this um paper 2. If you want, we can continue the 2 class, 1 or 2 class tomorrow. If you feel like it's enough, we can just stop here. Okay, just stop here and then we continue like next time when you need it. Okay, what do you think?
I
Do you
will
need more?
I will tell you later.
Can. Yeah, you can go back like and take a look at the questions and also the answers. Okay, I already gave you the answers. Yeah, you can go ahead and take a look. If you feel like you still need more, you just let me know. Yeah, maybe we can just do like just the morning one or just the afternoon one. Yeah, up to you. How many you need? Okay, you just let me know later. If you feel like it's okay, you can handle everything, then yeah, you just let me know. We just stop at here. Okay. Yeah, so that's our progress at this moment. So if no other question, we will stop here. Yeah. Okay, we will stop here. Okay, thank you, bye bye.